I forgot to record. From degree, and the first one's easy because you're right, that is a unit circle value. And 4 is a unit circle value. But 2 and 3, not so much. Not so much. You can use whatever reference you have. Give you a little hint as you start. You can multiply anything by 1, right? So essentially what I need is a ratio of degrees to radians or radians to degrees. Yes? So, how many degrees? Pi is an easy reference place on our unit circle, right? Yeah. How many degrees is pi? 180. So if I want to get from radians to degrees, so I want degrees is what I want to end up with, then I would do 180 over pi. If I want to get from degrees to radians, then I would do pi over 180. That's it. That's why I said quick 2-minute thing. This is on your unit circle, right? Pi over 3 is at what degree mark? 60. So unfortunately for y'all, you're going to have to be very, very fast on your feet with the unit circle. You might not have degrees on here. But it's 30, 45, 60, 90. This is to convert. So to convert from, this would end up in radians. So from degrees to radians, you multiply by pi over 180. To convert from radians to degrees, I could do this. Now, if it's a known spot on the unit circle, that should be an easy conversion for me without having to do any math. For example, the 45 degrees, what are the radians? What's the radian? Pi over 4. The other two might be a little bit more difficult. By the way, when I start talking about negative degrees, what am I talking about whenever I'm on here? Going backwards, going the other way, right? At negative 2.5 degrees, what is your radian measure? Here's what I would do with this one. Do what? So here, for this one. So from degrees to radians, I change this to a fraction, okay? And I'm going to multiply it by pi over 180. This would go, let me see, goes in 3, 15, 3, 30, 36 times 2. I got negative pi over 72. Is that what y'all got? Yep. Wait, why? Do you have to do that way? I just put it like that. It's better for it to be exact if you can be, and no decimals. We like fractions better. But if you had the decimal, it's not wrong. I just did it. That's my little shortcut for multiplying fractions. You don't. Okay. If I do negative 5 over 2 times pi over 180. Yes. So. So negative 5 pi over, what is that, 360? And then 5 and 360 simplify to 1 and 72. Radians. That's your answer. So yes, you try the negative 41 and see what happens. It's turned into a little longer than 2 minutes. Yeah. Oh, well, thank you so much. Good job. Oh, I forgot to record that. Let me ask y'all this. Oh dear, thank you. Okay, sorry guys if you're watching the recording. I'm really, really sorry. We dropped a special right triangle in the middle of a circle with a radius of 1. Okay, That would give me the x, that would tell me that my long side was the square root of 3 over 2. And without you having to do the math, just trust me that that's what it comes out to be. Okay? In other words, if I had this triangle, 30 degrees, this is 90, this has to be 60. If this is 1, this is going to be square root of 3 over 2, right? And then this one is going to be 1/2. That's where this point is coming from. I hate, we needed to do a whole day on the unit circle. Oh my goodness. Okay, I did not know. I thought she started pre-cal with unit circle. I'm sorry. I apologize.
First semester we did
At the
it. We
end.
did it towards the end.
All right, so that's where these points are coming from. So the coordinates here, right, at 30 degrees, which is pi over 6 radians, is square root of 3 over 2 and 1/2. Now here's the significance of these points. If I came here and asked you for the cosine of 30 degrees or the cosine of pi over 6, because those are the same things, yes? Do we agree? The cosine is your x-coordinate. So this is, come on, the square root of 3 over 2. Guess what the y-coordinate is? The sine. The sine of 30 degrees is 1/2. The sine of pi over 6, which is the same thing, is 1/2. Are you all with me? Mm-hmm. This is a lot to throw at you this quick. Okay? Some people memorize this just as is. I always, every time I sit down, I have to think about my little triangles there because that's how I remember it. Because I derived it when I first learned it, and that's just what sticks in my memory. Now, if you look, there are a lot of numbers on here, and there are a lot of values, there are a lot of degrees, and a lot of radians, right? So this goes through, and she does not have the degrees on here, and a lot of that is because we don't use degrees a lot once we get past trig. And mostly we're in radians, and that's why. But I would definitely still have, I'd probably take a Sharpie marker on here, and I would probably mark those degrees just so you remember, because it is handy to know sometimes, all right? One other thing, there's 3 main basic trig functions, sine, cosine, and what's the third one? Tangent. And so the tangent, and if you look right up here, it says tangent theta, and theta is just the measure of an angle, right? You all know what theta is? Tangent of theta is the ratio of sine divided by cosine. This is why she gave me this for y'all, and I realize that now. Mm-hmm. Okay. Yeah.
I thought you said it was like that means that one is positive.
In the middle of the circle.
Do what? Oh, yeah, that tells you, because if you look, all these values are the same, right?
Like this one, all of them are positive.
Your x and your y's, right? That's telling you that essentially, because sine is your y, right? It's telling you what the coordinates look like. It's telling you your x is negative and your y is positive. The value outside of the box, again, I didn't create this, so I would do a few things different, but it's a great reference sheet, really. The number beside the boxed in values there, beside where it says, so see, it says square root of 3 over 2, 1/2. Those are the coordinates, so that's cosine, sine. The radians are pi over 6, so at pi over 6. The number on the outside, can you guess what that is? Square root of 3 over 3. She has done the math for you. That is tangent. Okay?
Oh, yeah.
So tangent of 30 degrees is square root of 3 over 3. Those are 3 basic. It's y over x. So it's sine divided by cosine. 1 half.
1/2 is the sine, and that, 3/2 is the.
This is cosine. This is sine. I always remember it because C comes before S and X comes before Y. That's the, and I mean, I still do that to this day. Okay, which one is it? She found tangent for every one of them. But here's the, well, because you will use this so much that, in fact, you should not leave pre-cal without having this, like, being able to tell me anything on here like that.
Sure.
Like, you should have, it's crucial. So, but that's okay, we'll get there. It's okay, it's okay, it's okay. I know, and that's part of the problem too. But what I'm getting at is that's on there, and it's not like she sat down and she figured each one out, because when you do it enough, and when you get through this course, you won't even need this. You'll say, oh my God, I can't believe I ever even needed to look at that, because you will have used them so much. And essentially, it makes your life a lot easier whenever you do know them. All right, so tell me this quickly. What is the cosine of 270 degrees? 0. Yes. What is the sine of negative pi over 4? Oh, you got to figure that one out whenever you look at it. Yes. Negative square root of 2 over 2. When I go negative radians, okay, where is pi over 4? It's up at 45 degrees, right? So I'm going to go backwards 45 degrees, and I'm looking at that value. So I'm actually at 7 pi over 4. Okay? So when you look at positive values, positive goes this way, negative goes this way. What is the tangent of 7 pi over 6? Or the tangent? No. Square root of 3 over 3. Find 7. You see it? That's the thing, and why you need to be so familiar with it. I would definitely be looking at this as you go, because it's. I made my kids take quiz after quiz. I made them take a radian quiz on it. Then I made them take a degree quiz on it. Then I made them take a degree and radian quiz on it. Then I made them take a degree radian and coordinate quiz, and then I made them take a degree radian coordinate sine cosine tangent quiz on it, where they had to fill the whole thing out.
Oh, she gave it to us, I think, like 3 days ago.
We didn't.
And then the other half of you have never
She
seen
told
it
us to
before.
just remember the first quadrant and then leave.
Once you derive the first quadrant using those triangles, because see here, this is my 45, 45, 90, and then here's another 30, 60, 90. Once you derive the first quadrant, it's easy to find all the rest, right? Okay, but the radians and the degrees are the only thing you have to kind of add and subtract and do that. But other than that, if you look at your coordinates, they're all the same. It's just whether they're positive or negative. So, yes. So this would be 45 degrees. Oh, yes, yes, yes. So a 45, 45, 90 triangle. Let me do it the same way that it is on the circle. That's terrible. So if my hypotenuse is 1, that means that each side square root 2 over 2. And 45 degrees is the same thing as pi over 4. Y'all, I must apologize. I had no idea y'all did not get to the unit circle. Okay, why do you think? Why would the tangent be undefined there? And if you think about your graphs, which we were supposed to talk about today, did y'all at least get to the sine, cosine, tangent graphs?
I remember seeing those. We never did get there.
Okay, so I know y'all got to must know functions. She didn't have them on must know functions.
You never on those other functions, but we never really did.
Okay, so sine, cosine, and sine and cosine are waves, right? They're and we'll talk about this in depth tomorrow. Your quiz will be Friday, not tomorrow. Your quiz is going to be on some trig functions, not on the other stuff before. Okay. All right. But the tangent has asymptotes in between. It can go like that. Yeah. It looks kind of like a cubic in the middle, and it goes on. But anyway, we'll definitely get to all that. But what I'm getting at is those asymptotes are happening when it's undefined, when you're dividing by 0. Okay. It'll all start to make more sense. I'm going to post some probably unit circle work for homework tonight because we need it. Okay, we need some unit circle practice. You have to get that.